Hey, what's up, y'all? Thanks so much for joining me on today's video, Repetition and Animation Part 1, where we are going to learn how to use a couple foundational coding tools, for loops and if statements, as well as cover how to get another input source, this time the keyboard, to create repetition and control animation in sketches like the one that you're seeing going behind me now. So one of the things that computers are really great at is repeating a task over and over and over really quickly with a high degree of precision, right? Um, and for loops allow us to kind of take advantage of that. So the syntax for a for loop is going to be for, right? And then you need to have some kind of counter, like how many times have we repeated an action. In this case, we're going to just start with using an integer, and we'll name it I, and we'll set it equal to 0, right? So this is sort of our counter. Then we need some kind of conditional, right, to say when do we stop, like how many times should we repeat, right? So if I say I is less than 5, every time this for loop runs, it's going to check and make sure the counter is still within the limit of this conditional, right? And then we need to have some way of incrementing or decrementing the counter, right? So every time we repeat this task, we need to say, okay, we did it once, right? Or we did it twice, or we did it 3 times, right? So in this case, I'm just going to say I plus plus, right? And that is a little bit of a shorthand for saying I equals I plus it 1, right? And so shorthand for this expression here, you can just say I plus plus, right? So you're just adding 1 to itself. You'll close that parenthesis, you'll open a curly bracket, and you'll close a curly bracket here. And then any code that you put in here gets repeated for as many times as you've set your for loop up to run, right? So let's take a look and kind of see how this might work, how this would unfold, right? So our compiler is going to get to the for loop. It's going to say, okay, let's take our counter and initialize it at 0, because that's what we've set it up to do, right? Is 0 less than 5? Why, yes it is. Let's go ahead and run all the code in here. When we get to the end, let's add 1 to our counter, so now our counter is equal to 1. And let's go back up to the top and check and see, hey, is that still less than 5? Is 1 less than 5? Yes it is. Let's go ahead and run the code. Okay, we're finished. Let's add. Now our counter is 2. Is 2 less than 5? Yes. Run the code. Add. Is 3 less than 5? Yes. Run the code. Add. Is 4 less than 5? Yes, it is. Run the code. Add. Is 5 less than 5? No, it is not. So now this condition is no longer true, right? It's no longer returning true in this conditional because we've repeated enough, we've incremented our counter up to 5, right? And that is no longer going to be less than 5, so it will exit this loop. Okay, so let's take a look at how this is going to work in our code. So I've just got a sketch kind of pulled up for us here, and a setup and a draw loop, and size of the canvas 640 by 480. Let's put a for loop in our setup loop here. We'll say for int I equals 0 as long as I is less than 5, I plus plus, oops, curly brackets. Let's just see print line I, just to kind of see how this is going to work, right? So what we should see in the console is 0, 1, 2, 3, 4, right? So we want it to happen 5 times, but since we're starting at 0, we're not actually going to get 1 through 5, we're going to get 0 through 4. So let's take a look at what's going to happen now when I run the sketch. Okay, and you can see exactly as I was anticipating, I'm going to get 0, 1, 2, 3, and 4. And that's just printing out my counter, or I, right? This counter variable that I'm using. Okay, so let's take this and move it into our draw function here and see if we can start using this to draw some shapes more than one time. Let's say background 0 for now. And let's say every time you run through this loop, I would like for you to draw a rect at x equals 0, 0, and then let's create a couple variables for ourselves. Let's say rect height or rect width. Let's make this like 25, and let's say rect height equals like 100, just to see what that looks like. And we'll say rect okay, right? So this is actually drawing 5 of them, but we can't see all 5 of them because they're stacked one on top of another, right? Because they haven't changed position. So one cool thing about these for loops, right, is that we've got this counter, and we looked at the map function in the previous videos, right? And so we know that we actually have this predictable value that's going to change, and we know what the range is going to be. So we can actually use this counter variable here inside of a map function to change parameters about how we're drawing this rectangle. So like if I wanted to draw the rectangle somewhere else, right, every single time, what I could do is I could say, how about x position? Let's change the x position, right? So that's going to be, we're going to map I, which we know goes between 0 and 4, right? And let's map this between 0 and width. And then instead, we'll have x here. Okay, that's pretty cool, right? So we're seeing 4 of them. I was expecting 5, right? And the reason that we can't see this 5th one is because the last one is being drawn. My rect mode is in default, so it's drawing these rectangles from the top left corner, right? So if I want that to be fixed, maybe I can say rect mode center. Cool. And now let's also, just so we can see this a little better, let's do height divided by 2. Now you can see these are evenly spread out across the window. I don't really want these to get cut off like that though. So I'm going to change this range here to be rect width divided by 2, and then width minus rect width divided by 2. That way both of those rectangles on either end are still on the screen. Nice, right? So you can see this for loop. We're mapping the counter variable to one of the parameters of our rectangles, and we can just kind of spread these out, right? And let's also, okay, so let's say I want reps. Let's call this horizontal reps, right? Horizontal reps. And right now it's equal to 5. So if I take this and I replace this here, and because we're counting from 0, I know it's actually going to go from 0 to 4 instead of 0 to 5. So I would just say number of reps minus 1. And I get the same thing. But if I come in here and I say 8, let's say I say 8 instead, now it's going to repeat this 8 times, and this mapping will spread out all of these rectangles evenly 8 times, right? And so you can see there's a really powerful way to kind of create different patterns with just a few really simple lines of code. So let's play around with how things look a little bit, right? What else could I do? I could map I, if I wanted to, let's say I want to map it to the height of the rectangle, right? So what I'm going to do now is, I think I want a few more of these, however, really quickly. Let me just get that. Okay, that's looking a little bit more like our original sketch. Let's cram a few more in. Let's see what that looks like. Okay, I think that looks a lot closer to what we had before, right? So what if I want to, every time I repeat, so this is the first repetition, second, third, fourth, fifth, sixth, right? I want it to get a little bit shorter. What I can do is I can say, how about this? Float h equals map I between 0 and horizontal reps minus 1. And I want this to go, so the first time I want it to be all the way, right? Rect h, right? And then I want the last repetition, right, to be like 10% of that. So maybe I'll say rect h times 0.1. And now, oh, I have to actually use this variable. So now I should get sort of like that nice little decreasing like cornucopia shape. Yeah, okay. That looks nice. And if I wanted to change, you know, sort of how much or how little, right, then I can kind of control that. What else can I do with this? I could change I could map the color, right, of my shapes inside of this for loop. So let's say, you know, let's start with fill 25500. Just so we're going to color all of them red, right? And then if I decide, hey, I'm going to make a let's map I0 horizontal reps minus 1. And I want it to be all the way red here, and I want it to be not quite so red here. So I can say 255, let's go down to 20. And then instead of hard coding this, I'm going to use that variable that I'm mapping with I. And I get this nice little gradient effect, right? That might be a little bit darker than I want. So let's come back in here and say something like, let's try 70 and see what that looks like. Okay, that looks pretty nice. I like kind of this gradient that I've got going from bright red to dark red here. So at this point, let's take a look. So now you know how to make repetitions here in one dimension, right? Let's think about how we might nest some for loops to actually make repetitions in 2 dimensions, right? So what I can do is I can actually take all of this code and put it inside of another for loop, right? So I'm going to say for int, usually you would go the other way. You would say I and then j, but since this one's already written, I'll just start with j. We're also going to start at 0, right? J is less than, let's think about vertical reps, right? J plus plus, right? And we're going to put, oh, I have not created that yet, so we'll say int vert reps. And let's say this is equal to 3 for now, just to see what that looks like, right? What we're going to do is we're going to take this for loop and stick it inside of this one, right? And this is going to happen 3 times, right? Because we've set it to 3. And this is going to happen 25 times because we've set it to 25. But we can now take this j, this counter, and use it to map things like our y position, right? So I might come in here and I might say float y equals map j, which I know goes from 0 to vert reps minus 1. And I want this to go from 0 to height, right? So the first time I want j to be 0, the next time I want it to be in the middle, and the last time I want it to be equal to height. I'm mapping j, which is going from 0 to 2, 0, 1, and 2. So now I'm expecting to get 3 of my horizontal patterns spread out vertically between 0 and height, as long as I come in here and I say draw it at y, which is this mapped value. Nice. Okay, I kind of like that. Let's increase that a little bit, I think, so that we get this looking a little more like we did before. Yeah, this is looking a little closer to the example, right? So you can see I've got all 5 of my repetitions all facing the same direction. So, okay, at this point, now I want to control only, or I only want to change like some of these, right? So we're going to need to, you know, figure out on what kind of condition should I flip this one or flip that one, right? To get that original example code that we had from before. So let's take a look at the if statement, right? So an if statement is going to evaluate a condition, and then if that condition is true, it will run the code inside of its curly brackets. If not, it will just exit, right? So all I have to do is write if, open a parenthesis, and then I have to give it some kind of condition, right? And so we've used one before, right? Where in our for loops where we're saying, is the counter variable less than the limit, right? So that's one of the conditions, right? We've also, where am I going to write this? So we've got the less than condition. We've got a greater than conditional, right? We've got also less than and equal to, or equal to, greater than and equal to, or simply just equal to. So these are all of our different conditions, right? So let's say I wanted, when I want this one to flip. This is j is equal to 0, right? This is the first vertical repetition. So I could say, sorry, I was pointing here to this top, right? So if I want this one to flip, right, I can say if j is equal to 0, right, then we'll write, this is code to flip horizontal pattern. Right? So let's see how that's going to work. If this conditional is true, it should run this code. If it's false, it will simply skip the code. So here I can say, let's do this. We'll say if j is equal to 0, right? What I want to do is, and I think what we're going to need to do also is say float x, right? We'll say x is equal to mapping all of this, but instead of it being the regular mapping, I want to switch this range around, and I want the largest, oh, no, I'm sorry, I don't want to mess with x. I want to mess with the height. So over here, I'm going to say h, actually. And I would say h is equal to this mapping, but instead of starting at the full height and going down to just 20% of it, I want to start at 20% and grow to the full height. And that should give me this. Now, I can also say else, right, like this, because what would happen if I didn't have this else statement and I didn't move this here is that when j is equal to 0, it would set this mapping, but then before I draw the rectangle, it's just going to draw this mapping anyway, so it wouldn't actually work. And let's just look at that, right? So if it's set up like this, where even though j is equal to 0 the first time this runs, it's mapping it like we think it should, this line of code here is still coming after. So I either can just move this after this one, right? And now this one is flipped, or I can say, this, right? So if j is equal to 0, map it backwards. Otherwise, else, if it is not equal to 0, if this is false, do this. Okay, pretty cool, right? Now, if I want to flip the other ones, like let's say, so this is 0, 1, 2, 3, and 4. So if I want to flip this one as well, and actually, I think I don't want to flip the even ones if I want it to look like what I was doing before. I want it to be the odd ones, right? So there are a couple of other logical operators that we have available to us. And we can actually put more than one conditional in the same if statement, right? So I could say if j is equal to 1, 2 pipe, these are vertical slashes, right? Or, right, j is equal to 3, then run this code. And then I could put this code inside of here. So now there are 2 conditions under which it will run. And I could use 2 if statements, but this is just a better and cleaner way to write it. It'll also just be a little faster because you're only having one if statement that you're checking for. So I can come in here and I can say if j is equal to 1 or j is equal to 3. Let's see what that looks like. All right, so now this is working pretty well, right? Unfortunately, though, if I were to come up here and say, you know what, I want this to be a little more crowded, let's make this 8, and let's make this a little shorter so they don't overlap. Let me undo this so that you can actually see the working code that we had. Right, so this works the way that we have it written. But if I want to come up and just change some of my parameters here, this is not going to work, right? I'd have to go back and explicitly, now that I have more than just 5 repetitions vertically, right? It works for the when 0, 1, 2, 3, 4, but I haven't written anything for 5 or 7, right? So I could put a bunch more code in here, but that would not be very efficient, and also would just mean like anytime I want to change it, I have to come back here and change it. So fortunately, there's a better way to do that. Let's take a look at how we're going to do that. And we're going to use what's called the modulo operator, right? And this little guy looks like a percent sign, and returns the remainder of a division problems, right? So if I say 10 modulo 2, right? 10 divided by 2 is 5, right? And there's no remainder. So I'm going to get 0, right? If I say 10 modulo 3, right? What's going to happen is 10 divided by 3 is 3 with a remainder of 1. So this is going to return 1, right? Really, really powerful operator, because now I can come in and if I use modulo 2, I can check for whether or not a number is even or odd, right? Because if I say 0 modulo 2, 2 goes into 0 0 times and there's no remainder. So you're going to get 0, right? Because the only thing that's left over is just the original number. You didn't actually do any division, can't go in at all, it'll return a 0, right? If I say 1 modulo 2, same thing's going to happen. 2 goes into 1 0 times, remainder 1, right? So it's going to return this remainder. So that's going to equal 1. If I say 2 modulo 2, 2 goes into 2 one time, remainder 0. So this is going to return 0. If I say 3 modulo 2, 2 goes into 3 one time, remainder 1, right? So this is going to give me 1. If I say 4 modulo 2, 2 goes into 4 twice, but the remainder is 0. So this is going to return 0. So you can see the pattern here, right? Odd numbers return 1 when I do modulo 2. Even numbers return 0 when I do modulo 2. So if I go back into my code, and instead of using this equals sign here, if I say j modulo 2, right? So whatever this number is, whatever vertical repetition we're on, divided by 2, what is the remainder, right? If that remainder is equal to 1, I know it's an odd number. And that means anytime I'm on an odd repetition, 1, 3, 5, or 7, right? Because that repetition number divided by 2 gives me a remainder of 1, it will have the backwards mapping for the height. Otherwise, if it's an even number, it'll have the regular mapping. So let's run this and see if I did everything right, and it works. Awesome. Okay, so now this is looking a lot more like our original sketch, right? And I can come up in here and I can make this any number without having to worry about whether or not it's going to flip this mapping for me, right? I've used this conditional instead of just, checking to see if j itself is equal to something, right? As you can see, if I wanted to be a little more thoughtful about this, I'd probably need to make the height of the shapes somewhat kind of related to the number of repetitions. But for now, I kind of know what I want it to look like, so I'm just kind of hard coding some of that. The other thing that I'm thinking is, maybe I want to the gradient, I had it as well so that it was always brightest when the shape was biggest. So I want to, when I'm flipping the pattern around in the other direction, right, I think I'm going to want to change this mapping as well. So I can come over here and say float r for my red value, right? When it's an even number, do your regular thing. When it's an odd number, let's flip this around and say 70, 255, and we'll get rid of this and see how that looks. Okay, so now, right, we've got this gradient going in both directions. So I'm liking the way that's looking. All right, so let's look at how we can kind of play around with maybe like nesting some mappings. I think I'm also going to say no stroke here. And make these just like a little bit taller. Okay, so this will be fine for now. So I'm going to play around with the height. You remember in the original example code, the kind of the rectangles were like kind of growing and shrinking, right? So if I take this height mapping, right, and instead of having this range be fixed, right, I'm actually going to be changing that range. What I can do, it'll change how this behaves, right? So let's set this up a little bit differently. So let's have a rectangle height. Let's do this. Let's say max rect height, and then min rect height, and then we're going to say we'll have this variable as well, rect h, right? Actually, no, we don't need that anymore. So we're going to set this up so that we have a maximum rectangle height and a minimum rectangle height, like this. And let's just run this. This should be the exact same, right? But now I can come here and I can say the minimum rectangle height equals map, like, let's just use the mouse for a second, mouse x, which I know goes between 0 and 640, right? So if I change that minimum, I know that usually I want it to be 25. Let's just say I make it at the end of its range equal to 135. Right? So let's see what happens if I do this. What's going to happen is this map function here, right, will originally it's going to go from 25 to 135 depending on where we are in our repetition. But as I start to move the mouse across the screen, it will then go from 25 being the minimum all the way to 135 being the minimum. And so when 135 is the minimum and it's equal to that maximum, right, then all of these should be the same height. And you see they kind of overlap here, right? So you can see as I move my mouse across the screen, that minimum value, right, is now growing. And so it's just going to be the same height when I have it set up that way. And this is kind of a cool little pattern as well. But it's not exactly what we had from before. So I'm going to come over here and I'm going to also use the same parameter or the same input, right? This mouse x, max rectangle height equals map mouse x, which again we know goes from 0 to 640. I'm going to do it the opposite because I want it to start at 135 and I want it to go down to 25. And so when I do that, these two values, which are both being mapped differently to mouse x, will change. And that's how I'm getting this fun little animation where they kind of change shapes like this, right? Now, this is cool and it's a playable visual, and I could, if I wanted to play it along with my music or my piece or whatever, using the finger on the trackpad. Finger is getting kind of tired though, so if I don't want to manually kind of have to drive this, how am I going to do it, right? Let's take a look. Let me make let's say instead of mouse x, I need a different variable. So I could just say int counter, right? And I'm going to initialize that variable counter equals 0, right? And I am going to say, instead of mouse x, right, I want to map counter. Now, we know counter is going to start at 0 because we set it equal to 0 here in setup, but how much is it going to increase to, right? Because we're at the end of every draw loop here, right? We're going to just add 1 to the counter. But how can we tell processing, hey, stop counting, or this is the limit for the counter? Well, we learned how to use those if statements before. Let's use another one. We'll say if counter is less than, let's say counter limit, then go ahead and increase it. And let's make the counter limit, let's make it, let's start with like 200, right? Let's just see what that gives us, right? So it's going to be 0 when I start the sketch. It's immediately going to start counting up, right, to 200. And when it gets to 200, it should stop, right? Because after it's no longer, less than 200, right? This will be false, and so it will stop adding to itself. Okay, that's a little bit slow, so I might make that limit a little smaller. Oh, well, no, I also need to make sure that I type in the correct range. Let's go back. Cool. Okay. So let's think about how we want to control this animation now, right? So I liked what I was doing where I was moving the mouse left and right, right? So I might do something like this. Right? I would need that counter when it gets to the max, when it gets to that limit, I would need it to turn around, right? So let's make a new, oh, this is going to be a fun data type. We haven't done this before. A boolean, right? So this is just like a value that will either return true or false, right? So let's say forward. And we're going to set this equal to true, right? So I'm thinking I'm moving my mouse like forward and backward, right? So we'll set boolean forward equal to true, and we'll say if forward, right? If that boolean is true, then do whatever is inside of this, right? And we'll say while you're moving forward and the counter is less than the counter limit, add 1 to itself. Otherwise, I would like for forward to be false, right? And then we can say, well, if forward is true, do all this stuff. Otherwise, if it's false, then as long as counter is greater than 0, I want you to subtract 1 from it, right? And then if it's equal to or less than 0, I want you to turn around and I want forward to be true. So this will become true, and then we'll start executing this code. So let's see what that looks like. All right, super cool. So this is the final product here, and hopefully you guys have a pretty good idea of how to use for loops and if statements in your sketches to create repetitions and manage animation and change parameters based on only certain conditions. Tune in for the next video where we'll look at how we can continue using for loops and if statements to create some more repetitious patterns.